All pre-flight checks completed, the B-52 pilot taxis to the takeoff runway. The upper fin of the X-15 extends through a notch in the trailing edge of the B-52 wing, so the flaps of the B-52 cannot be used for takeoff or landing. The ground support vehicles are soon left behind as the B-52's speed rapidly increases. On a hot day, more than 12,000 feet of runway is required to achieve liftoff at 170 to 180 knots. Snugly tucked in the X-15 cockpit, the pilot is no doubt recalling the good old days before wing mounting, when he had to squeeze into the cockpit down through the bomb bay. This maneuver was accompanied by considerable huffing and puffing, and a big sigh of relief when he was finally strapped in the seat. Nothing to do now but sit back, relax, mentally help the B-52 pilot with his flying. Wing mounting of the X-15 permits the ejection seat to be utilized in an emergency, while the aircraft is still attached to the B-52 shackles. Launch checks continue as the pilot tests the attitude control rocket. The high-altitude control system used when the X-15 is on an altitude flight profile above the usable atmosphere. At extremely high altitudes, the conventional aerodynamic control surfaces are not sufficiently responsive for complete flight control, so attitude control rockets are necessary. Pitch and yaw rockets are located in the nose. Roll rockets are located on each wingtip. The underside of the X-15 is now building up a coating of frost on the outside of the liquid oxygen tank due to the intense cold of the liquid oxygen at a temperature of minus 300 degrees Fahrenheit. The auxiliary power units are now started. Note the exhaust trail going over the horizontal stabilizer. Launch. Light roll-off occurs as the shackles release. The X-15 engine is started, and the aircraft accelerates rapidly, quickly leaving the B-52 far behind. On this flight, the plan called for a buildup of 1,500 pounds per square foot of dynamic pressure before pull-up. Again the launch, photographed by X-15 camera number 1. Note the rapid acceleration as the aircraft drops away from the B-52, and the steep climb-out angle. Speed brakes are extended to permit longer burning time of the engine propellants and provide added aircraft stability during re-entry. Peak altitude of 317,000 feet planned for this flight is now achieved. X-15 camera number 5 shows the pilot's reaction to zero-G state. Camera number 6 shows the control panel and the weightless condition. Note the pages on the pilot's flight checklist. The planned peak altitude accomplished, the aircraft starts on the downhill side of the parabola. As the descent angle increases, the horizon gradually disappears out of the picture. Now the pull-out to level flight, and the horizon once again is seen behind the tail of the aircraft. The pilot banks the X-15 to visually judge for himself the landing site relative to his position. The speed brakes close and the pilot guides the aircraft into an approach pattern for a landing on Rogers Dry Lake. Residual propellants are jettisoned prior to landing to relieve the aircraft of all excess weight. The lower portion of the vertical fin, which extends below the landing gear and would consequently dig in on touchdown, is jettisoned with a recovery parachute attached. At a pattern speed of 300 knots, the pilot reserves the extension of the landing gear and flaps to avoid drag increase until the landing is reasonably well assured. Because the main landing skids are located far back in the fuselage, the pilot cannot hold the nose up on touchdown, resulting in a rather jarring contact of the nose gear to the ground. Touchdown is made at a sinking speed of approximately 2 feet per second and a forward velocity of 200 miles per hour. The average slide-out distance is 5,000 to 6,000 feet. Brakes are not necessary with this landing gear configuration, as the skid ground contact serves to slow down the aircraft. Landing successfully completed, the ground support equipment and personnel necessary to deactivate the systems approach the X-15. Assist the pilot in getting out of the cockpit and prepare the aircraft for transport back to the hangar. An aerial view from a helicopter shows the support equipment at destination required to conduct an X-15 flight operation. The ground crew has finished the initial details of aircraft recovery, and the post-landing checklist is almost complete. Relieved of his helmet, pilot Joe Walker is happy to hear that welcome greeting. "That was a good one, Joe." And he obviously agrees. Willing hands disconnect his leads and assist the pilot from the cockpit. The flight tension's over, the relaxed pilot enters the van to have his flight suit removed and post-flight physiological checks completed. Successful missions of the X-15 are indicated by the symbols painted on the van. The B-52, affectionately known as the High and the Mighty One, roars over at a low altitude and executes a Chandelle maneuver to announce mission accomplished. And so ends another X-15 flight mission, adding more basic information and scientific knowledge to our space effort and increasing man's capability to reach his ultimate goal, the conquest of space.